Hello again and welcome back. In this video I will show you some changes I made on my Guede GTB 16500 Vario bench drill machine. And I will also show you how I did what I did, so that in case you are interested you can do the same with your machine. This is not just for the Guede bench drill machine. The same way you can do it in almost any other bench drill machine or even floor machines if you want to make these changes. As you can see in this picture, I added a digital readout for the Z for the quill movement, and also added to my X and Y axis on the XY compound I have on this machine. The X and Y readout is connected to an Arduino box with a display which shows the changes as I rotate the handle. This is well, it's mainly for comfort, because reading the one, especially the Y axis reading, is a bit complicated because it's below the table, especially if if it's like this right now, it's covered by the actual table, so it's not possible. On the X it is a bit different. It's quite a bit easier to read because it's placed horizontally, so the moves can easily be followed. The Arduino is connected through a cable, a thin 4-wire cable, and you can zero the display here, or also on the Arduino box there is a button here. If I press that, then it will set X to 0 or Y to 0. The actual box is made for 3 axes, but I am using only the X and Y. The Z is not connected, because I will explain in a short while. Anyway, this box is not only reading and displaying the values, it is also providing power for the X and Y DROs. And the power is provided actually by this red LED, which has about 3 volt over the LED, and I use that as a 3 volt supply to these two readouts, and that works. That seems to work fine, so I don't need to have a battery in the units. It's enough with the power provided by the Arduino box. Also, it is possible to change to inches if I want to change to inches, and changing between inch and millimeter is possible in each of them individually. So if I change, it will change this display to millimeters or inches, and it will display, of course, the right value. For the Z, I decided to have a separate solution, and that is a separate display on this side. And the reason for that is simply because I wanted to have a fast response, a much faster response than the Arduino can manage, and also that I wanted the actual Z display to be on the left side of the machine, because I am operating the machine with my right hand, and most of the time I am a little bit to the left of the machine, except when I am driving the compound table, because that is actually more done from the right side of the machine. So having the XY display on the right side is a better solution than having it on the left side. I don't know, most people are happy with having it on the right side, both all three on the right side, but I thought that this was a good solution for me, so that's why I didn't implement the third axis on or in the Arduino. Or it is actually implemented, so if you are interested in the same solution, I can give you the code, Arduino code, and you can copy it and just uncomment the Z, and then you have all three. The Z actual reader for the Z is a little bit different from the X and Y, because this one is just a flat box, and it's an aluminium bar with it's not the capacitive reading or sensor or whatever this strip is called. It's a capacitive strip, and the way I attach this is pretty, I mean, I think it's a good solution, because it's just an aluminium L bracket here, and that goes in under this black box, which is the controller for the drill machine. And I drilled and tapped 2 holes here, which holds this L bracket, and that the other side is screwed to this black box with the sensors. And because this aluminium bracket adds some distance to from the drill machine head, I added plastic rubber foam on all sides to have an equal distance, so that the controller box for the bench drill machine is well, looks nice this way, I think. And then also on the bottom, as this moves down, it will drag the sensor, the distance sensor. I attach this to this collar, which is fixed or attached to the quill. So when the quill moves down, the collar moves down, and that drags the distance sensor. Previously, this was the only readout provided in this machine, so it was nothing digital, and it works if you don't need any precision, but I wanted something better, because in many situations it is easier to have a digital display, and especially in metalworks it's better to have a higher precision. The X-axis sensor is also attached using L brackets, and one reason for that was that I wanted to have a good distance between the top of the table and the readout. And if I would have not used these L brackets, then all these screws underneath would be on the way, so it wouldn't be possible to install it except if I raise this too high above the table, and that is definitely something I didn't want to do, because I want this clearance here. Also, in the next step, maybe I will add some kind of protection here, so nothing will end up on my readout. Another advantage of this solution is that, as you can see, this display goes to sleep after a while. It will automatically switch off. But when that happens, my DRO still displays the value where it was last time. And as soon as, of course, as soon as I move, it will wake up again, and it will also transfer the same value to my Arduino. The Y-axis is, as you can see, it's also sleeping now, but that is not attached using L bracket, because while it might seem to be a good idea, because that way I could read even this display when I'm using it, but that is actually not true, because the only position that would be possible is if the table is at the maximum end of it, but if it is like that, like it is now, then it would not be possible anyway, so it doesn't really matter. So that's why I chose to install it this way underneath, just straight aluminium piece on both ends, and then of course another little bit thinner bent aluminium sheet which connects the actual readout, which is sleeping now, but if we wake up, if we move, it will wake up also, and it will start displaying the values. The display units are simply attached using another L bracket, aluminium L bracket, which I cut off the back part of it here, so that I can attach it to the motor screw on this side, and then I bent it a little bit to get a good clearance and also the right distance. So when I when I have to move the quill down, it's not on the way, and it's easy to operate. On the other side, for the Z, I had the same solution or similar solution, also an L bracket here holding this display, and it's well, this way it's easy to operate and zero it if I want to, or switch it off. This display doesn't go to sleep, and I didn't implement any power supply, so currently it's on battery. I will see how much battery it will use. If it's using too much, then I will connect this also to the same, so that it can be powered from the Arduino. But right now I have to remember to switch it off when I leave the room, because well, I don't want to have it on all the time. As you see, if you switch this off and then on again, it's a random value which is displayed. It's not zero, and it's not the same as the one it had before, but it's just a random value. So every time I have to push the zero to set the zero, but that is not an issue at all, because normally you just drive this down, the quill down to your to the required position you want to use it, and then normally you zero that anyway, so it doesn't really matter. The X and Y display are also showing a random value if the current is removed, which is done as soon as I switch off everything here. Like I switch it off now, it will turn off automatically, of course, and then when I switch it on, sometimes it's zero, sometimes it's just a random value. But that is again not an issue. But if I switch it off here on the original display, then it gets back to the same as it had before, and that is because these ones have some kind of a memory. If there is battery or power provided to the unit, then it will keep the same value. But that doesn't it's a non-issue, so I don't care about that. Of course, it's much neater if it would keep the old value, but it's no big deal. The main thing is that it is when it goes to sleep, it's not actually zero, but it continues showing the value, because this is connected through data communication to the Arduino. The Arduino is all the time asking for a current value, otherwise it would not be able to detect any changes. But when this goes to sleep, it will continue responding for the requests from the Arduino and will give the same reading as it's having as it had when it went to sleep. So it works quite well. That's it for now, and I hope this gives you some ideas on how to solve the X, Y, and Z readings if you want to have a digital readout on your machine. Of course, the X and Y is most important if you are also using the machine as a mill, but even for drilling, I mean, precise positioning of the drill is much easier to do with a digital readout than it is if you have to read the number of tones with your handle and then try to read especially these unreadable digits on this handle. So that I think it's a good addition to any bench drill machine which has an XY compound. And for the Z is of course it's almost a must today. I think it is much better than just having the old mechanical type, which is okay for wood, but for metal it is really not. One more thing why I decided to separate XY from the Z. The main reason was that I want to be able to remove the compound easily, and right now if I want to remove it I just have to unscrew, of course, from the drill machine table and release these strips here, unplug the two X and Y connections from the Arduino box, and then just lift and remove, and by doing that I can still read the Z. So the Z is still there and it's not connected. Of course that could have been solved by using a switch saying to the Arduino that now it only needs to read the Z, but I think this is a better solution. So that's it for now. Thank you very much and goodbye.